Welcome to Madagascar. This is 5 Romeo 8 Sierra Victor. Today I'm going to tell you about my antenna project, which has taken the last year. I arrived in Madagascar about a year ago and had no antenna, had nothing set up beforehand, so everything that came here either had to be shipped across the ocean from the US where I lived or hand carried in my luggage. Here's the plan I came up with before leaving. The easy part of the antenna is the hex beam itself. The hex beam was ordered from K4KIO. I had researched other hex beams on the web, and K4KIO looked like both the best price and had good reviews, and I would say that it actually has worked out to be a great antenna. The materials are top notch. There are plenty of people that are happy with them, as am I. The 6 fiberglass arms that comprise the hex beam attach to a central metal plate. On the bottom of that plate is a socket, and that sits on top of the pipe and attaches to it with a hex nut, and I also added another retention screw just to make sure that that was a good solid connection. The choice of mast was critical because every year there's cyclonic activity in Madagascar from November to about March, so I needed this thing to withstand high winds. The mast I went with was from Spiderbeam. It's a heavy-duty 10-meter aluminum telescoping mast. I don't think that a mast meant for television antenna service would really cut it. The shelves for the thrust bearing and the rotor were fabricated from local materials, and I'll show more of that in a moment. The rotor has to be fed by a control cable that supplies both the directional signal and the power, and of course there has to be a coax cable that goes up to the antenna that has enough slack in it that it can rotate freely as the antenna rotates around. I went with Belden 9913 F7 as a real low loss coax, although my run isn't actually, it didn't turn out to be that long, but I didn't know that when I was packing. The critical part of this whole system, though, is to have something very solid for the antenna to sit upon. So I looked into towers. I looked into something called a telecommunications pylon, which I think is a cell phone tower, because I was quoted about $16,000 cost of putting that up. I ended up going with what I thought I would, a piece of wood. So I went with a 4-meter long piece of pine that is anchored in the ground with concrete rocks. I added some rebar as an anchor. And just as a little bit of extra stormproofing, I added a copper ground rod at the base of the antenna, not really so much to protect from a direct strike, but to help prevent the accumulation of a static charge that might draw lightning. The coax itself, where it enters the house, is protected with a polyphaser system that's grounded to the house ground. An important part of the setup is the thrust bearing, which is on the upper shelf. And the job of the thrust bearing is to take the load off of the rotor. The mast passes up through the thrust bearing, which consists of 2 rings. The lower metal ring is attached to the shelf or to the tower, and the upper is attached to the mast, and the upper ring rotates on low friction bearings relative to the lower ring. So the weight of the mast and of the antenna attached to the mast is borne by that thrust bearing, and that takes the load off of the rotor at the bottom, which instead of having to worry about forces laterally, only has to worry about movement in one plane, counterclockwise or clockwise rotation. Since the beam mast is such a long lever arm, in wind it can really put a lot of torsion on the rotor, so having the thrust bearing right above that rotor relieves those lateral stresses, and this hopefully will add to the longevity of the rotor. Finding the wooden post turned out to be a project in itself. There are hardware stores here that sell paint and nails and screws, but not so much 4-meter long wooden posts for putting up your antenna. I had to go to a mill where they planed down pine trees. So one of those pine trees in that pile eventually became the antenna support. And these fellows have a machine. They have a planing machine and a sawing machine. So out of that circular trunk, they cut several planks, some of which were rounded on the sides, but the center of it became the post. It's 15 centimeters by 15 centimeters by 4 meters, and it was quite dangerous. The machine that they have, you throw the log on and it spits it out the other end, and everyone kind of jumps back when the log hits it, and there's wood flying all over the place. And these guys were definitely not working according to union regulations with goggles and protection and so on. It was a dangerous job, so I appreciate that they did it and I didn't have to. So at the end of it, I ended up with a 4 meter long squared off log that I transported to the house on an ox cart. Well, I didn't transport, I had it transported. And then a 2 meter ditch was dug, the log was put into it, and the rest is history.
There's a support for the hex beam. The vertical pole is 4 meters in total. 2 meters are underground in concrete, and then the other 2 meters are above ground. And I've used angle iron to attach 2 supports, one for the rotor on the bottom, and it has the 4 holes to mount the rotor. And then up top, we have another with a circle in the middle around the thrust bearing that'll be mounted on top also with 4 screw holes. So the whole thing is meant to hold up the telescoping antenna, or mast rather. There's the mast. The bottom part is an adapter because the G450A rotor has a relatively small receptacle, so the part that fits into it has to be smaller than the diameter that the hex beam, rather the Spiderbeam mast, comes in. So this is a 10-meter heavy-duty Spiderbeam mast, and it comes in multiple sections, all of which are small enough to fit into aircraft luggage. So I shipped this thing, carried it by hand, and then put it into checked luggage. And I've got it disassembled because it's got to fit into this mast support system. And I've attached the upper platen, which will eventually be where the hex beam elements mount. And I'll put that up first to get a sense of how long the guy lines need to be. In the box over there are the elements and the center post, which goes on top of the hex beam, which is what you attach all of the elements to, and which has the coax cable connection.
The diameter of various components is an important design consideration. The G450 rotor can accommodate a mast of up to 50 millimeters external diameter. However, the Spiderbeam that I'm using at its base is 70 millimeters, hence the need to have an adapter. As for the thrust bearing, the GS065, it can accommodate a pipe of about 66 millimeters. The second segment from the bottom of the Spiderbeam mast is about 65 millimeters, so it's a very tight fit. However, there is clearance. The way the thrust bearing is designed, normally you would put shims between the circumferential screws and the mast, and those shims would distribute the force of the screws against the mast so that you don't have the point contact of the head of the screw against the mast itself. I didn't have room for that, and I don't think it actually is that big an issue. I do have the screws directly abutting the mast, and they seem to be holding well, and the weight of the mast is divided amongst the 8 screws, so I think that's a reasonable way to arrange that load. Yaesu quite reasonably suggests that before anything is installed, the rotor and the rotor controller be set up on the desktop and the cable between them tested. Setting up this cable is the most daunting part of this entire project, and Yaesu really don't make it that easy. One end of the cable has a DIN connector that will plug into the bottom of the rotor, and that connector has to be soldered, so various colors of wire are connected to various numbered connections on the DIN connector. That's not too bad. The other end, however, has to be connected to a plastic connector that plugs into the back of the controller, and this really is a pain. They provide just enough little crimp connections that they say you can crimp with your pliers, and then those crimped ends insert into a plastic molex connector that will insert onto the back of the controller unit. Now here's the problem though. The molex connector on the back of the controller unit does not match up to the molex connector that they provide. In the diagram, it shows that there are round and square holes on the back of the controller unit, and that was true. However, there were no corresponding geometry on the molex connector that had to plug into it. So after I had crimped and prepared the one connector, I tried multiple times to force the two together, and before I realized you just cannot put a round plug into a square hole. Consequently, I found a different way of doing it. In fact, I followed the way that the controller was set up in the past. Originally, it had terminal strips on the back, so I pulled the connector off and replaced it with a terminal strip.
The only silver lining to this business is that I get to use my banana clippers. I don't get to use these very often, mainly when working on coax, but they'll do a great job cutting through and giving me a clean cut. Fortunately, I have to do this one-handed because I'm holding the camera with the other hand. No problem. There you go. Nice, clean cut. The cover lifts off not too bad. There's the two retention screws in the middle of the bottom of the cabinet, and then the 4 feet on the bottom, and then there are 2 screws on the side, and then this part pulls off. Here's the inside of the rotor controller. Little power section, controls up in the front, and then a little circuit board up on top. Shouldn't be too hard to get this connector out. Looks like it'll just squeeze together and push out. There you go. So we'll rewire that puppy. As mentioned, although it's a 6-wire connector, there are only 5 connected.
Skipping ahead a bit, this is how it ended up, with the terminal strip in the back, wires on the upper side coming from the inside of the controller unit. I put a little rubber grommet on there just to protect them, and on the bottom, the cable coming in from outside from the rotor itself. The other thing that occurred to me while I was at it is that it would be nice, since the country runs on 230 volt, to convert the unit over from 110 to 230. According to the schematic, it's wired for both, but the schematic that comes in the manual doesn't quite make it clear how to make that adjustment. Looking around the internet a bit, though, I was able to find this diagram from an older version of the manual that is archived on the hamcity.com website, and it shows which terminals to connect for the various voltages. So I switched it over.
While in here, here's the transformer on the primary side. So this is the KT28 on the spec sheet. Since I'm in a country where the voltage is 230, and this is a 110 unit purchased in the US, I'm going to convert it over to do 220 operation by moving the brown wire, which is currently on pin number 2, from left to right. They're labeled 0, 1, 2, 3. By moving that to pin 3, it should make the entire unit work on 220, 230 volts. Here's a look at the finished antenna. Not entirely finished. There's still some finishing touches in terms of running wire and securing it and so on, but this is functional. So at the base is the Yaesu G450 rotor, and you can see the wire running into it. I selected a thicker control wire than I probably needed because I wasn't sure of the distance of the run. The longer the distance, the thicker the wires. So I, in fact, could have gotten away with smaller conductors, but it doesn't hurt. And there's a rubber gasket that covers where the wire enters the rotor, and I've also secured it with a bit of coax seal and then some electrical tape, so it's well and truly secured, I would hope, against weather. And the rotor is sitting on the angle iron support that I made. There are 4 hexagonally tipped screws that secure the motor down to that plate, and that is going nowhere. That's pretty secure. Up a little bit, you can see the U-rings that secure the adapter into the base of the motor. The adapter doesn't handle the diameter that the hex beam comes in, so rather the Spiderbeam mast comes in. So there's a little adapter. You can see a little bit of aluminum just above the top of the black rotor, and then there's a small rubber or plastic, maybe, spacer between the adapter and the beginning of the Spiderbeam mast. A little bit further up, there's the screw that holds the adapter in place, as well as 1 screw hole from an abortive attempt to drill through. It didn't quite line up. Since then, I've learned that the way to make the hole lineup on both sides is to just go through one side with the drill, continue until you get to the other side, and then you're assured that the holes are on axis. So continuing upward, there is an O-ring showing one of the expansion joints of the Spiderbeam, the telescoping sections. That there's a little Allen nut that holds everything together, and those are tightened down not too far because you don't want to crush it, but secure. And then up again is the upper bracket, and you can see the thrust bearing on top of it. The tolerances on this were pretty tight. In order to get the Spiderbeam mast up through the thrust bearing, this is the one of the larger thrust bearings that's available, also from Yaesu, and it's very close to the diameter of the mast. And looking at the bottom of it, you can see that there's just a couple millimeters clearance on each side. So it really had to be aligned very carefully to make sure that the mast is absolutely vertical and that the plate that holds it is completely centered. And then looking down from the top, making sure that the space on each side of the mast is equal. And that has allowed the mast to rotate freely. Up a little higher, and we may get into the sun, are the two supports with guy rings. Those guy rings float on top of each telescoping section, so the mast can float, can turn freely within them. And they're at the two levels, and then up at the top is the connection to the antenna itself and some excess coax cable. So the guying was done somewhat expeditiously using what was available. So here's one of my guy tie-offs. I used an anchor and an eye screw and just screwed into the side of the building. That's brick and concrete, so that should be, I hope, fairly secure, and tied it off with perhaps not entirely regulation knots. And at the other end, on the mast, I have carabiners just to make sure that the strings don't get cut by the sharp edges or potentially sharp edges of the guy ring that goes around the mast. The other standoff is similar in the building, and then I have one over here in a tree. So I don't know how secure these will be when weather gets rough. There we go. But good enough for now. And I think when weather does begin to become an issue and we get into cyclone season, I may lower that mast to the level of the house, and then it'll be in the lee of the house and should be protected. Here's the other attachment on the house that I didn't show. Of note, the way that I brought the coax cable down, I ran it along one of the guys. I took it off at the level of the higher guy attachment, and then it just runs down the guy string and is tied off with electrical tape and cable ties, that sort of thing. And then it separates at one point to run alongside the house, and the ties tie down to another one of those eye screws. Here's the rotor in position in the shack. Right now it's pointed roughly towards Australia. We'll turn it on. Lights up. And we can rotate it around. We'll bring it up towards the north. Due to the location of the shack being in the southern hemisphere, I wanted the rotor to be able to rotate freely through the northern pole. So I've set up my rotor probably a little differently so that there's no stop at the north position. My stop, the zero resting position, is at the south pole. And that way I get to sweep through the northern hemisphere. That's pointed roughly towards Europe, maybe a little more over towards Europe. And the Great Arc Path for my location actually takes me through Europe and then over to the northern US and Canada on that bearing. So in order to rotate through most of the US, Canada, Europe, Central Asia, Russia, China, I wanted to be able to do the sweep through the northern hemisphere.
and that's why it's set up like that. And it works very smoothly, no problems controlling the antenna from the shack. So now that I have the rotor, what do I do with it? Well, one excellent resource is the azimuthal map that's available from NS6T, November Sierra 6 Tango, .net on his website. That shows which direction you have to point the antenna to reach anything according to the Great Circle path. Another thing I find myself doing a lot is going to the DX cluster site, DX Summit. When you click on one of the spotted sites, you can bring up VOA cap predictions, which are great, but it'll also show you the rotor direction. So doing that, I found that I'm being heard quite a bit better. The pileups are not only larger, but I can hear through them much better, to some degree due to the directivity of the hex beam, but also the ability to rotate it, towards the source. So I would consider this a successful project, even though it took me almost a year to get built. So 73 from Antananarivo, Madagascar. This is 5 Romeo 8 Sierra Victor, clear.